Hello, Math 301. I'm going to make a quick video going over the old midterm from last semester and talking about, how to answer it. And I'll maybe at the end, I'll talk a little bit about some things that aren't on here that you should know. Anyways, this first one starts with a small ball at a point and is rolled up a hill to a different point and has three forces acting on it. Find the combined force. And so that's pretty simple. The force is just the sum. So it's F1 plus F2 plus F3. And so in vector notation with components, you get 1i, you get, looks like negative 2j plus 1j is minus 1j. And then the k component is going to be 2k minus 2k plus k. So it's going to be 1. So that's our force. And the work done, remember work is equal to force dotted displacement. And so the displacement vector is just the ending point minus the starting point. And so that will be 1, 1, 2. And so if we dot those two vectors, you get 1 times 1 plus negative 1 times 1 plus 2 times 1. And that will just be 2 joules. Compute the component of F that is parallel to the displacement. So that's just the projection of F onto D. The formula for that, remember, is F dotted with D over D dotted with D times the vector D. And so that becomes 2, which we just computed. D dotted with itself looks like we get 1 plus 1 plus 4, so it's 6. And then you just multiply that by the vector D, which is 1, 1, 2. So you could leave it like that, or you could write it as 1/3, 1/3, 2/3. Either way is fine. Find the angle between them. Remember that cosine of theta is equal to the magnitude of F. Oh, sorry, not the magnitude of F. It's F dot D divided by the magnitude of F. F dotted with D divided by the magnitude of F divided by the magnitude of D. And so that will equal 2 over the magnitude of F looks like root 3 times the magnitude of D, which is root 6. So that looks like 2 over root 18. And then to find theta, you have to do cosine inverse. So theta equals cosine inverse of 2 over root 18. And that's it. Is the force being applied optimally? And the answer is no, because the angle between them is, if it was optimal, then the angle between them would be 0, and that's not 0. So to make it optimal, we want F to be parallel to D. So want to be parallel to D, so it needs to be a scalar multiple. So it looks like if we add the vector 2, 0, 2, 1 would work. So F4 equaling 0, 2, 1 would lead to the resultant vector. So F plus F4 would then actually just equal D. It would be 1, 1, 2, which equals D. And so that would be the force you needed. Find the equation of the plane that is parallel to two vectors and contains the point. So we have a point, and we need a normal vector. So the normal vector is going to just be the cross product of these two vectors. So I call this V1 and V2. And it's the cross product of V1 cross V2. And so that's going to be the IJK 1, 2, 3, negative 1, 0, 2. You take their cross product, you get 4 minus 0. And then in the J component, you get 2 plus 3, so negative 5. And then the K component, you get 0 plus 2. So negative 4, 5, 2 is our normal vector. So that's our normal vector. So then the plane is just 4 times x minus the x value, minus 5 times y minus the y value of the point, plus 2 times z minus 17 equals 0. So that's the equation of the plane. Find the area of the triangle formed by the 3 points on the plane. So they give us 3 points on the plane. And the idea actually is that this point is the point we started with. And if you add these vectors to them, to that point, you get that point and you get that point. And so it makes a little triangle where you start at the point 3. This is like if this is the point 3 to 17. Then following V1 gets you actually to the first point. So following V1 gets you to point 4, 420. And then following V2 gets you to the other point. So if you followed it by negative 102, that gets you to the point 2, 219. So that's V2. And so the idea is that the area of the triangle is half the area of the parallelogram, which is the magnitude of the cross product of those two guys. And so the area is equal to 1/2 the magnitude of V1 cross V2. V1 cross V2. And we already computed V1 cross V2. And so it's equal to 1/2 the magnitude of n, which we already got. And so that's the square root of 16 plus 25 plus 4. And so it's root 45. Oops. Root, where's the back button? I guess I can just erase. Whoops. Erase. It's going to be root 45 over 2. So that's the area of the parallelogram. Or the triangle. Area of triangle. Okay, find the equation of the line that's the intersection of 2 planes. And they already tell you what point is in both of them. So we have a point, we just need the equation of a vector. And so we need a normal vector. We need the normal vector n, which will be the cross product of the normal vector for one plane. So n1, and then the other vector will be n2. And so it's going to be n1 cross n2, which will be I, j, k, and then the vector n1 is 1, 1, 1. The vector n2 is 1, 1, negative 2. So I take their cross product and I get negative 2 minus 1 is minus 3. And then for crossing out him, you get negative 2 minus 1 again, but then we make it positive. So it's 3 because you have to do it a negative again. And then k, you get 0. And so that's our normal vector. And so the equation of the line r of t is our point 1, 1, 1 as a vector plus t times n. And so that's going to be the vector 1 minus 3t, 1 plus 3t. And then it looks like the z component will just be 1 because it's always going to be 1. So the line actually doesn't travel in the z direction. It has a fixed z value. Okay. Find the distance from that line to the origin. In order to do that, the formula is PQ cross V magnitude over the magnitude of V, where V in this case is just the vector that defines our line, which is negative 3, 3, 0. PQ, so Q is a point on the plane, so that's 1, 1, or P, sorry. P will be the point 1, 1, 1. That's a point on our line. And then Q is the point we want the distance from, so Q is 0, 0, 0. And so PQ will be negative 1, negative 1, negative 1. Then what we do is we're going to cross those. So PQ cross V equals IJK negative 3. Well, I guess actually I should do PQ first. It will just, I mean, we're taking the magnitude, so it really doesn't matter the order, but that's okay. Negative 1, negative 1, negative 3, 3, 0. If you cross out the I, you get minus 3, minus 3, so it's 3. If you cross out J's column, you get negative 1 times 0, which is 0. And then 3 minus 3, but it's positive, and so it's 3. And then for the k, you get -3 plus -3. Right, this one I have to actually write -3 minus -3 times 1 is 3, and so it's going to be -6. Okay, and so this is -6. And so we want the magnitude of that vector. The magnitude of that vector is going to be 9 plus 9 plus 36, and then divided by the magnitude of v, which the magnitude of v is 9 plus 9 root 18. And so you get 18 plus 36 is what, 54? Root 54 divided by 18. I actually think that simplifies quite nicely, because 18 goes in there, what, 3 times? So this equals 3, or root 3, because it's root, yeah, it's going to be root 3. So that's kind of nice. Nice. Okay. Next one, the trajectory question. So we give you a trajectory. I changed the numbers on it to make it nicer. Compute the speed of the trajectory. And so r prime is the first thing we have to do to get the speed. So r prime is going to be, you take the derivative, we have to use the product rule. So it's e to the t sine of t, and then plus the derivative, or regular e to t times the derivative of sine of t, which is cosine t. And then the derivative of this would be root 2 e to the t. And then this one will be e to the t cosine t minus e to the t sine t. So that's r prime of t. Now we need to take its magnitude. That's going to be the speed of our trajectory. And so the magnitude is you have to square each of those components, and so you have to FOIL it. And so you get e to the 2t, because that's e to the t squared, sine squared t. And then you need the cross term, which is going to be plus 2 e to the 2t cosine t sine t. And then plus e to the 2t cosine squared t. That's just the first thing squared. And square root this whole thing. And then it'll be plus that one. The next term is easy. It's just going to be 2 e to the 2t, so that's good. And then plus squaring this thing will be the exact same as this, except for there's going to be a minus sign here. And so you get e to the 2t cosine squared t minus 2e to the 2t cosine t sine t, which is the important thing because it's going to cancel out. And then you get plus e to the 2t sine squared t. So that cancels with that. And so this simplifies actually rather nicely. And you should notice that something that on the exam, it's going to simplify somewhat. It has to, otherwise it's too mean. This sine squared plus this cosine squared gives us a 1. Same with that cosine squared and that sine squared. And so what I'm left with is square root e to the 2t plus 2e to the 2t, and then plus another e to the 2t, because this one combines with that one to give me an e to the 2t, and that one combines with that one to give me an e to the 2t. And so what are we left with is square root of 4e to the 2t, which actually is a perfect square. It's just 2e to the t. So that is what the speed is, 2e to the t. Find the total distance traveled from t equals 0 to t equals 4. So that's going to be the integral from 0 to 4 of the speed, which is 2e to the t dt. Integral of that is just 2e to the t, evaluated from 0 to 4. If you plug in 4, you get 2e to the 4th, minus when you plug in 0, you get 2. And so that's the total distance traveled. It's not parameterized arc length because the magnitude of vt does not equal 1. And so we need to set up what s is. S is the integral from 0 to t of 2e to the t dt. This integrates to 2e to the t minus when you plug in 0, which is minus 2. And so this is what s is as a function of t, and so I need to solve for t. So it's s plus 2 equals 2e to the t, then divide both sides by 2, and then take the natural log. And so t is going to be ln of s plus 2 over 2. And so that's the substitution you need to make in order to make it parameterized by arc length. Finally, we have one more problem with a bunch of sines and cosines. And without computing the unit tangent vector, we want to figure out what this dot product is. And so this is a little tricky because the unit tangent vector, maybe you're not thinking about it, but remember the unit tangent vector is related to the derivative. It's just you take the derivative and you divide by the magnitude and you get t hat. And so the idea is that the unit tangent vector is actually just a scalar multiple of this. And so the dot product of this and r of t will be the same as the dot product of r prime and r. And we know that r prime dot r equals 0 if and only if the magnitude of r is constant. And so that's why it says how far away from the origin is the trajectory. And so is it a fixed distance? And so we want to compute that. So let's compute r of t. If you compute the magnitude of r of t, you get the square root of 8 sine squared t plus 16 cosine squared t plus, oh, that should be a 3. Yeah, that's not gonna work. Okay, sorry, this was a mistake. That needs to be a 3, or else this isn't gonna work. It's because that needs to be a 9. And then that should be minus, so then plus sine squared. The reason is it needs to be constant, otherwise this problem doesn't work. And so that should be 9 sine squared plus 9 cosine squared, which sine squared plus cosine squared is 1, so this just equals 9. So this is root 9, which is 3. So it has a constant radius of 3, and so so it is a fixed. So r dotted with t hat equals 0 because it's on the surface of a sphere. Compute the curvature, the unit tangent vector, and the unit normal vector. So in order to get those things, we have to compute the derivatives. So compute the derivatives, we get root 8 cosine t, negative 3 sine t, and negative cosine t. The magnitude of that will be square root of, let's see, this will be 8 cosine squared plus 9 sine squared plus cosine squared. And so just like before, this is going to be 3. That will equal 3. And so that means t hat is just going to be this vector over 3, root 8 over 3 cosine t, negative sine t, and negative 1/3 cosine t. So that's t hat. We need to take the derivative of that, t hat derivative, to get the normal vector. And the derivative of that will be negative root 8 over 3 sine t, negative cosine t, and then this will be 1/3 sine t. And then in order to get the unit normal vector, we need to take the magnitude of that. The magnitude of that will be 8/9 sine squared t plus cosine squared t plus 1/9 sine squared t. So it actually has unit magnitude already. It's already equal to 1. So it equals 1. And then we get the following. So the normal unit normal vector is t hat prime over the magnitude of t hat prime. And so that's going to be, actually it's just equal to t hat prime. So it's just going to be negative root 8 over 3 sine t, negative cosine t, 1/3 sine t. So that's the normal vector, and then the curvature is going to be the magnitude of t hat prime of t. Yes. Let me think about this for a second. Is that true? Yeah, I think it has to be that, because otherwise, because t hat magnitude is always 1, so it has to be the derivative, and then over the magnitude of r prime of t. And so this is going to be 1/3, and so that's the answer. So the things that we want, the normal vector, the unit tangent vector, and the curvature are all the following. Things that weren't covered in here that you should probably know for the exam. So one thing is the torque. I said torque will be on there. Remember that torque is your radial vector cross your force being acted on it. So if you have some fulcrum, you have some radial vector r, and you have some force acting on it F, then torque is just their cross product, and it's some vector that will go in a direction that's perpendicular to both of them. The other thing is the magnitude of the torque is equal to the magnitude of the cross product, which is equal actually to the magnitude of one times the magnitude of the other times the sine of the angle between them. And so that's another way you can get an angle. So that's something you need to know. And then the last thing I would say is intersection of two lines. Intersection of two lines. And remember how to do that. If you have one line, r of t, and another line, L of S, which have 3 components, then you just set their components equal to each other. And so, for instance, maybe I should actually kind of give it a little bit more thing. So if R of t is like has the first component, X is a function of t, Y is a function of t, Z is a function of t. I should give these ones. And then L of S is a different line with x2 as a function of s, y2 as a function of s, and z2 as a function of s. Then their intersections, you set those things equal to each other. x1 of t equals x2 of s, y1 of t equals y2 of s, and then z1 of t equals z2 of s. And then you solve for t and s that satisfies that system, and then you can plug it into either one to get the point where they intersect. And so that should cover everything you need. If you have any questions, feel free to email me. All right.